Hello, class. This is Professor Chapman, and what I'd like to do today is to go over some PowerPoint slides that I've created in order to help you understand the concepts involved with data visualization. In particular, there are two graphing routines that are introduced in Chapter 15, and I've created some PowerPoint slides to go along with that material. Dr. Conrad has already posted a video on Matplotlib that you all should watch. And so I don't mean to go over what she's already done. What I'd like to do is simply run through these PowerPoint slides that should assist you in understanding the various steps that are involved in these graphing routines. Now, there are two graphing routines that are introduced in Chapter 15, the first being Matplotlib, and then the second being Plotly. What are these programs? Well, Matplotlib and Plotly are two common visualization tools that are used in Python. Matplotlib is quite possibly the simplest way to plot data in Python, and so that's what we covered first. Matplotlib generates simple plots by declaring each plot element explicitly in a logical manner. Plotly is another great visualization tool that's capable of handling geographical, scientific, statistical, and financial data. But it has certain advantages over Matplotlib. In particular, it creates more sophisticated plots using less code, and only a few lines of codes are necessary to create aesthetically pleasing interactive plots, as we shall see. Now, I've created some slides here to go along with Matplotlib, which again was covered in the video by Dr. Conrad. So Matplotlib, first of all, it's a library, which is a collection of modules that provide a wide range of graphing functionality. The most important one that we introduced was Pyplot. And this contains the number of functions that generate charts and plots. One function in this module is subplots. And this is used to generate one or more plots in the same figure. So keep in mind the difference between a plot and a subplot. You can think of a plot as being sort of a line that's drawn on a graph, but subplots are really individual lines. So using subplots, you can generate multiple plots on the same figure. The plot method then, so you create subplots, which could be simply one or several, and then you use the plot method to plot the data that you're given. And then we use the show function to open a viewer and display the plot that we've generated. And this is an example which Dr. Conrad went over of how we do this. Now, one thing we can do in Matplotlib is we can do certain customizing, and we've seen how to do that in the video by setting the thickness of the line, titles, and labels for the axes, and also ticks. That is the markers that go on the axes. And we can use built-in styles. We talked about Seaborn, which is sort of a background chart style that helps you view the plots. We talked about making a scatter plot, and you use essentially the scatter method, which takes a list of X and Y values and plots each point. And the example then would be, to create a plot that we call AX, and by giving it sort of X values and Y values, which would be the square. We can also customize it by giving it a certain color and a certain size. We can generate data then to be displayed in our plot. And we've again covered that. Now, what I want to do is talk about Plotly, the other graphing package um, that's introduced in chapter 15. And what Plotly is, it's a collection of functions and classes for making interactive graphs. To make a plot, you specify the data and then pass it to a graph object. Now, you can think of a graph object as being a display screen, but it could be something other than simply a screen that you're graphing on. In particular, it could be a map. And that's what we'll see is important as far as chapter 15 and chapter 16 is concerned. Now, the data we store in a list. So an example would be X values here, and we create a list that ranges, in this case, up to 11. And then we'll create essentially Y values. We'll square these values in this range of X values. Now, to create a scatter plot, then what we do is we define the data, and we take that to be an instance of scatter. So what we would do is we would import from Plotly, in this case, the class scatter, and then we'd create an instance of it, which we call data, by giving it the X and Y values. We could also instead import the bar class from Plotly and create a bar graph then by giving it defining the data to be the X and Y values of this bar graph. Now, the other thing we often import, or we import, is something called offline. We used to generate it online, but it was found more flexible to use the offline mode. And so the online mode hasn't been supported as much as the offline mode. The offline mode is one in which we essentially generate HTML code, which then can appear in any browser window. And the nice thing about it is it will resize according to your browser window. Another class that we import is something called layout. And the layout class is used to essentially do that and specify the layout of our graph. And so we can specify titles, labels, and other formatting directives for visualizations. An example would be where here I create an instance of layout, which I call my layout, by essentially giving it a title, giving it an x-axis configuration and a y-axis configuration. All of these will come clearer when we go over the example. Now, data can be defined as a dictionary in a list. So another way of defining data, there's different ways to define data. Here we could simply define data as a scatter plot, or we could define data as a bar, as an instances of a bar. But we can also define data as a dictionary in a list. And so an example here, same thing, is where we would take our data and we would define it, as a list, and then a dictionary inside this list. And here we give type scatter. So instead of on the previous slide, here we define data as this instance of a scatter. This is another way of doing it. We simply by saying type equals scatter is another way of saying create an instance of a scatter class. And here is how we give it the X values, the Y values, and we can also give it a mode. In this case, markers. And so what we're saying is that what we want you to do is when you graph this as a scatter, we're going to use markers. And a marker, it basically is a point. So we could have had other mode. We could have had lines that we're we would draw lines instead of points, in which case we would be drawing lines from one x to the xy value to the next xy value. Now, we can, as I was saying, we can create sophisticated displays. And this is an example how we can. We can introduce something called a color scale. A color scale being something like the color of the rainbows that runs from red, orange, yellow, green, blue, indigo, violet. And so that different values may have different colors. And so an example here might be one where we use one popular color scale called Viridis. And what we're going to do is we're going to color something, squares that we introduce, our data as squares, and we're going to create a color bar. So a color bar will be something on the side of our graph that says, you know, basically this color represents this value. Likewise, just as data can be defined as a dictionary, the layout can also be written as a dictionary. So in the previous example here, we defined my layout as being an instance of layout with these parameters here. What we could do is define it instead. My layout is written as a dictionary, where we give it a title, the x-axis, and the y-axis in this format. So there's some flexibility here, and this is a way in which it's easier for us to see what values and what choices we've made in our layout. Again, just like we did with matplotlib, we could have multiple plots in a data list. In that case, we would create one dictionary for each data series, and then put these dictionaries in the data list. So the previous example that I showed here was, here we had data, and we have a list here. We can see the square brackets, but here's the curly bracket that defines a dictionary. Well, we could add another dictionary to this with the same things, and in that way we would create a second plot that would go on the same figure. Now, to have multiple plots share the same axes, we again use these subplots module, and then we make a figure that holds all the charts that will be made, and we use the add trace method to add each data series to the overall figure. So we create an overall figure and then add all of these subplots to it. So this is an example of how we would do it. Essentially, we would add all of these elements to our figure, and then we would, as I said, we would plot it offline. And so that gives us an HTML code, which we then call subplots.html and can open in a browser window. The real advantage, as far as we're concerned, is that Plotly allows us to plot global data sets. And in particular, there's something called scattered geo. And scattered geo is a chart type that we import. And what it does is it creates a scatter plot of geographical data on a map. And an example, here's where we create data as an instance of scattered geo with these parameters that we give it. And here, like lawns and lats, what are these are going to be? These are going to be longitudinal and latitude values. So these are going to be lists. The first being a list of longitude, the second be a list of latitudes, And then it's going to plot, since it's a scatter plot, it's going to put a marker at each longitude, latitude that we specify in the list. Another way of doing this, rather than, in this case, as a list, is to create a dictionary. And so here we do the same thing, but here, rather than calling it as an instance of this class scatter geo, we simply say the type is scatter geo. And then here's where we give our longitude, here's where we give our latitude, but here's where we can do some more sophisticated things. We could use hover text. And so what that means when we have these markers, if we hover over them, then we will display values, corresponding values for that longitude and latitude. And this is going to be a list that goes along with these longitudes and latitudes. Then we set our markers, and what we can do with our markers is we can set the size of it, and we can set the size so that it represents the magnitude. So for the magnitude that corresponds to that longitude and latitude, say of an earthquake, we would then have it, the size of the marker be proportional to it. We could set a color that corresponds to it, and we can pick that color from a color scale. The system will do it for us. We can reverse the scale, so rather than going from, say, red to blue, it goes from blue to red. And then we can give a color bar a title, so it knows that the colors represent the magnitude of the earthquake. Then we would create simply my layout. We can give it a title, and then we create a figure by giving it the data that we've created here and the layout that we've created here. So let's go now to the code we had to make this clear. So what we did here is, here's our Plotly. We had to import it. And then what we're saying here is from Plotly, this graphing package, we're going to import from the graphic objects in it, we're going to import two, scatter geo and layout. And then we're also going to import offline so we can create the HTML code to go along with it. And so then we've discussed the data in a previous lecture. But what down here is that once we have this data, here's where we graph it. Here's where we define the data for a graph. And what we do, again, we create a list. In this case, we're only going to graph, say, earthquakes. We're going to only have a single plot. And so our dictionary, here's our type, longitude, latitude, hover text that we created. We created up here. The hover text here is where we extracted is the properties title. Well, this turns out to be essentially the distance from the nearest city. So if you hover over it, it'll tell you the distance from the nearest city. And then our size, color, magnitude, and our color bar. And then we give our layout. The layout was just going to give it a title, earthquakes. We could add other things to our layout. And if you're interested in making it more sophisticated, you could see what other parameters this class has. By default, we're only going to illustrate earthquakes, but there are other things we could add to the layout. And then we create our figure from this data here, which comes from up here, from this dictionary. lawns that we've added here, coordinates 0, that's longitude, and then latitude. So that's where we've got the data, which we then fill in here. And the hovered text, likewise, we got from here. And then the layout, we come from here, we create the figure, and then lastly, we plot it. And when we plot it, we plot this figure here. And when we plot it, we save it as HTML code called global earthquakes. And then we have it here. And then once we have it here, as we saw, we could then display it in a browser, or we could actually import and this IPython module, which then allows us to display the HTML code in Colab. So we could use this import statement to import the HTML code and display it. So I'm going to post these PowerPoint slides so you can reference them if it helps. And I wish you luck with then displaying, creating your own Python charts.